Hi everyone. Hopefully this internet interruption won't be a frequent occurrence to this talk. Okay, I'm Steven Kolawole. I'm from Nigeria, and I'm an ML researcher. Yeah, I primarily do research with ML Collective, and my research interests focus on efficient machine learning, basically. Yeah, and I'm really excited to be here today.
All right. Stephen, may I ask you to speak a little bit clearlier?
Okay. All right, sure. That wouldn't be
Okay,
an
so
issue
the
at all.
stage is yours and have fun.
Okay, thank you very much. Uh, okay, so hi everyone once again. So in this talk, I'll be going to a work I did recently, which was on site-to-speech modeling for sign language understanding um, in sub-Saharan Africa specifically. And in this talk, I'll be going to my setup, my experiment process, and also the lessons I learned while working on this project. Yeah. Okay, so usually I try to I'm quite amazed about, how far we've come. I'm quite amazed about how far we've come in machine learning development generally. This was in the 80s when the world technology was powered by steam engine, right? And what you're looking at is like a steam-powered SG post machine. Yeah. And so you point the data from one end and then, yeah, you retrieve your inference from the other end. Right? Okay, that's a joke actually. But this is a good litmus test for me to understand on this. This is a good litmus test for me to understand the technical depth of my audience in machine learning, basically. Yeah. So so if you could get this job, it means that you're solid with machine learning to a good extent. But if you can't get this job, then it means your knowledge of machine learning is probably scanty, or you're not, uh, really into machine learning, right? And I wish this is a physical talk, so I could conduct a poll, ask for people who get the joke and people who don't and people who don't, basically. So so I will try to I will try to I will try to simplify some of the machine learning terms in this talk, yeah, so that everybody could you know understand everything I'm basically talking about in this. Sorry. Okay, yeah. So this project started out as a fun project. It started out as a fun project, and it's an end-to-end working prototype that detects sign language meaning, images, and videos, which generate the equivalent voice of words that is being communicated by sign language. Everything is done in real time. Yeah, so there was this challenge back then, and then I participated in the challenge, and this was what I did. I tried to learn about 5 sign words, American Sign Language online, yeah, and then I created a very small data set, and with the data set, I was able to develop this, and then I won the challenge, yeah. And then I started thinking, can I possibly turn this into a research project? Can I work on this on a much larger scale? And then I started looking for people who might be able to, to assist me in the planning out of this project. Yeah. So the first person I reached out to is Opeyemi Shakade. She was a researcher at Data Science Nigeria back then. Currently, she's a PhD researcher at the University of Edinburgh in UK. So so I talked to Opeyemi about the project, and then yeah, we started trying to see where this work might fit in, right? Obviously, there are a lot of works being done on sign language, for the American Sign Language, especially for the British Sign Language, even for the Indian Sign Language. Yeah, so we needed to fill a spot, a spot that is currently, uh, a sport that is currently not being solved yet. Yeah. So, and then we started, reading literature on likes. And yeah, and then I met Dr. Babatunde Olushade, who is a senior lecturer, in data science at Cardiff Metropolitan University. And then we were working together and we realized that this work I've never been done before in Sub-Saharan Africa. I'm from Sub-Saharan Africa, so yeah, it makes sense for me to focus on the region, to do this kind of work. And then during our study, we realized that in Sub-Saharan Africa, this sign language, they come together, the hearing impaired, and then the larger population is one of the highest rates, in the world. And yeah, and there's no existing work that has been done to solve this problem in Sub-Saharan Africa. So we started working on this, and then I started training, and then I realized that the first iteration of the training I did it with Colab, and there was a particular day I had to stand in front of my laptop for 13 hours straight up, trying to train a model on Google Colab. Google Colab has this interactive environment, um, so yeah, you can't just leave it and go do some other stuff. You have to, interact with the with your collab ID, while working. So I joined the ML Collective, and yeah, I got a lot of very important feedback on the work, and I also got computational resources. And finally, I met Nayan Saxena, who was a maths and stats student at University of Toronto back then. But yeah, he graduated, so he's currently working as a data scientist at the Royal Bank of Canada. Yeah. So Nayan also assisted with the writing and the the subsequent improvement they suggested by the reviewers. So in the end, we had this. Yeah. So the work was accepted into a new week's workshop on machine learning for developing world late last year. Yeah. And then we went to a new iteration of revisions, and then trying to improve on the work, and then we published the work as a conference paper at the conference, the International Joint Conference on Artificial Intelligence, IJCAI, earlier this year. That was at March. Okay, so yeah, the story. So in this talk, I'll go to the motivation, the data set creation, and then the experiments, and then evaluation and deployment. Yeah, basically. So and yeah, the deployment and the demo. Yeah. So for the background, the motivation was to reduce the communication barrier between the hearing impaired community and the larger society, with a focus on Sub-Saharan Africa. This is because Sub-Saharan Africa is a region with most cases of hearing disabilities. And the way we plan to do this was to develop a lightweight sign-to-speech solution that works in real time. So the lack of solutions for this problem, we discovered that is mostly due to two factors. And the first one is that the sign language data in the region is extremely low resource. Actually, even languages, the mainstream language that we speak in Africa are extremely low resource. Not to talk more about, of sign language data. Even if the mainstream language is low resource, then you can be rest assured that the sign language data, sign language would probably be non-existent. Yeah. So yeah, and then there are increasing complexities and advanced tools we have to deploy these solutions in real life environments. Yeah, we realize that also. Okay, so and then we propose to do this by trying to create a novel data set for a sub-Saharan country sign language. Of course, without a data set, we can't really, build anything tangible. So yeah, we needed a novel data set, and for that we needed to create a data set for a sub-Saharan country sign language, and yeah, we made use of the Nigerian Sign Language as a case study. So there are lots of then we plan on trying to do sign to test conversion experiments and build several baseline models here, and we plan on deploying the best performing model for real-time usage, while converting the sign text to speech. Okay, so for the data set, we created over 8,000 images, and this was for, I think, 135 plus words and phrases. And then the way we did this was, I reached out to a TV sign language broadcaster, Amanda, and Amanda helped me out with the first iteration of the data set creation. Yeah. So I think during that time we had about maybe 2,000 images, and then I built a proof of concept, and then I went to two special education schools in Nigeria, and then I created a larger data set, you know, and that was how we arrived at the 8,000 images of number. So in the end, what we had was a widely dispersed data set of 20 individuals, 20 plus individuals, capturing diverse backgrounds and lighting conditions. One thing we try to account for is we want the model to be able to generalize very well, and then, work extremely well in the wild, right? And the way for us to ensure that is to make sure that the data separation is done in diverse background and lighting conditions, poor lighting conditions, and then good lighting conditions. So just trying to mimic how it might be utilized in the real world after deployment. So I started, data cleaning, and that reduced the images to 5,000 images. Basically, I had to remove all blurred images, and then images that are not, capturing the full length of the full length of the sign being performed. Yeah. So we have to do annotation for object detection. Object detection simply means that we want to detect an object in an image frame. In this instance, the object we're trying to detect is the sign, right? I mean, it's the sign being performed. And for us to be able to do that, we need to draw boundary boxes. Boundary boxes are like bounding boxes are like, you simply just draw a box. We call it annotation, basically. We draw boxes around the signs, and then, yeah, and then we save the annotations in a particular file format, so that we can use that for training. So the data that is entering the training pipeline is actually in two phases. So we have the images, and then we have the annotation, and the model is meant to, correlate the two with each other. Yeah. Okay. So then we started the experiment. So we tried out several models. Yeah. There was a yellow B5 model, and then we had a single shot detector using resonance 15, and finally there was a classification model using mobile net tool. So for the yellow model, we used text format annotations, and then we tried out different data augmentation techniques. Here is the hue saturation and value manipulation, which is just we're trying to adjust the lighting conditions, and then there's the scaling, which is basically zooming in and out, and we have like a left-right flipping, flipping that image this way, or flipping the image that way, and yeah. So that was the data augmentation part, and then we trained over 150 epochs in batch size of 16, and yeah. So this was our child after training here, and then you notice that the the recourse the position is quite high. And you can look at. I'm going to explain this later. But what you're looking at right here is called mean average position at 50% overlap, and this is at 95% overlap. Okay, so yeah, so we tried out the augmentation techniques. Yeah, that how to we perform zooming, and then flipping the image left right, and then training over 150 epochs in batch size of 16. And then what we had afterwards is this. And one thing I want you to pay attention to here is the recall score, which is quite high, and then the precision, which is also quite high. Yeah. And then map is known as mean average precision at 50% overlap, which is basically the original annotation box that, and then the predicted annotation box. Yeah. So this is at 50% overlap, and then this is at 100% overlap, at 95% overlap. So you can see that at 50% overlap, the accuracy was quite high. It was almost, I think that was 98% accuracy, while the 95% overlap was not really there, even though that was good performance. So we also tried out SSD, which is a single state detector using SNet 50 again. And ResNet 50 was already pre-trained on the Coco 2017 dataset. And so we performed images, we performed annotations. We already have the annotation file, so we converted everything to TF record format. Yeah, because we're making use of TensorFlow object detection API. The data, the data set that is being fed into a TF record format. So we have to convert images and annotations to TF record. Okay, so and then in terms of data augmentation, we tried out horizontal flipping, and then the scoping applied, and then we trained across 40,000 training steps. Okay, so for our final model, this was a classification model. So I discarded the annotations and trained with just the images. Yeah. And then I made use of MobileNet V2 as our classifier. MobileNet V2 was already pre-trained on ImageNet dataset. So we first of all try to use MobileNet V2. Basically what we're trying to do is transfer learning. So we first of all try to use MobileNet V2 as a feature extractor. Yeah. So we have like a dense layer on top of it, and then we trained across 60 epochs. Then we realized that the model wasn't really performing as well as expected. The loss wasn't decreasing rapidly. So we decided to fine-tune some of the layers in MobileNet V2. Apparently, there's like 152 layers in MobileNet V2. So we fine-tuned the 52 of the layers, and then we left 100 layers closing. Okay, so in the end, this was what we had. Yeah. So one thing we noticed that the loss in accuracy, the loss was quite high. Yeah, loss was quite high, and then immediately we started fine tuning. Then the loss started decreasing rapidly. I didn't know what happened here. I still can't do that. The loss decreased very rapidly. The same for the precision value, and then the same for the recall score. You can see that the recall was dragging, and then immediately we started fine tuning, it skyrocketed. Same goes for accuracy. Yeah. Okay, so in the end, this was what we had. Um, the recall score was at 0.95, which was the highest, for YOLO. And then we have SSD. SSD didn't really perform quite as well. And we realized that maybe the reason for that is we realized that when SSD is being deployed and used in dark corners, it has this weird habit of imagining shapes in every dark corner. Yeah, that wasn't very optimal for our use case. So we deployed the YOLO V5 mode. So in the deployment part, the model was converted to sign to text. So we had a text to speech conversion with Pytorch X3, which is like a library in Python for for text to speech conversion. Yeah. So after the conversion, we deployed the model on DeepStack server using Docker basically, and in the end, this was what we had. So right now, I want to show the demo. I don't know if my internet will be up for it. Yeah. Um, okay. Okay. This looks like my internet is not for it. Yeah. I'm so sorry about that. But there's a GitHub link at the end of this talk, so you could basically go to GitHub and try and play along with the just there's the video. Oh, okay, I have the video now. Let me see if this could work. Um,
Steven, we are facing quite a trouble with your internet, so can you just drop the link in the comments?
oh, okay, okay, great, great. All right. I'll drop the link in it.
Thank you.
Okay. Yeah. Okay, so some roadblocks we encountered while creating this work, working on this. There was the data set creation was hectic because I had to create a data set from scratch, which was like a tuner sign language data set, and I had to do this with my personal resources. I'm still an independent researcher, and then the easier part was having this idea of creating a data set. Yeah, but trying to see people who might be invested in the idea of trying to create a data set, it is not really something that was easy per se. So yeah, it was hard trying to find people. Of course, it's like a noble idea, you're trying to save the world, but yeah, not many people would be quite in it to, to work with that with you. Yeah. So the data set creation was very hectic, and the annotation was even more hectic because I had 8,000 images, and then I had to annotate the 8,000 images by hand. By annotation, I mean I had to draw boundary boxes around each of the images, each of the 8,000 images, and I did this by hand. So that was very hectic. And yeah, so when we submitted the paper to the International Joint Conference on Artificial Intelligence, one of the reviewers asked about, how we plan to provide, how we try to, put the signer's privacy, the how do we plan to protect the identity of the people who helped in the creation of the data set. And of course, privacy is like a huge concern in our world right now. And of course, there's the option of trying to blur out the faces of these people, but the face is actually a very important part of performing science. Yeah, because you might have I don't know, you want to dictate, you want to depict let's say a smile, and then yeah, you're doing something like this. Yeah. And if the face is blurred out, then it makes it harder for the neural network to recognize the sign that you're trying to perform, right? Yeah. So the face is like a very integral part of trying to create, trying to predict signs. But if we're blurring out the faces, then the model performance, we should expect a degrade in the performance of the model. Yeah. So basically what I've been trying to do, which I haven't really been able to do, is to try to ask all the signers to, to um to consent to the release of the dataset publicly, if they're fine with their faces being shown, but I've not really gotten around to that yet. Um, Okay, yeah. So finally, thanks to ML Collective for the computational resources. As I said in the beginning of this talk, the first iteration of the models were created on Google Colab, which was an interactive IDE. And while working on Google Colab, I mean, there was a day I had to stay in front of my laptop for 13 hours straight up. Yeah, because Colab is an interactive environment, and I have to keep using my laptop, I mean my computer, so that the model can continue training here. So it's very important. I mean, the fact that ML Collective could give out computational resources to build this project was, a very important part of the job. Okay, so very briefly, I'll go through some of the lessons I learned while working on this project, and most of them are coming from the uh, from the career perspective, basically. And if you're already, I don't know, a senior level or middle level engineer, some of this might not really matter to you. Okay, so the first is that most times, if you're an entry level engineer or even a mid-level engineer, or you're trying to transition from learning to working in the industry, most times we only need a big, just a single big project. Yeah. I mean, most times if the project is big enough and mind-blowing enough, then we have every leverage we need in our career, to take that big step forward. Yeah. So most times we only need a single big project, to get to the next level in our career. And then maybe we can find out what we want by working on that single big project. Yeah. I think this work was like a huge factor in my career choices. Basically, I don't know if you had that in the beginning, but um, I'm currently a machine learning researcher. And before I used to be an engineer, I mean a machine learning engineer, but this work was like the validation I needed, to go into research. And since then, I just realized that research is something that could really work out well for me. And also, I would say that we probably should overthink stuff, so let's just do stuff in as much as we catch that bug. Immediately we catch that bug to do the work. Yeah. Um, for example, during the data set creation, in fact, suppose this work entirely, suppose I got started on it this year, I don't think I would have been able to do it because now I'm more experienced, and then I've experienced more failures and more wins, and yeah, so I have this more pragmatic view on life now. Yeah. But back then, I think I was very smart, so it was very easy for me to, just get started, not thinking about how am I going to get the resources to create a data set. How am I going to interest people in joining me to create a data set? How am I going to, train my models? I mean, I need computational resources, but I didn't really overthink any of this. It was more like a one step at a time set. So, if you're in that phase of your career, where you're overthinking stuff, I'll probably say, in as much as you feel like doing this, then just get started and do it. Okay, so and finally, I would say we can have fun and being autistic at the same time. I like to group these two train of thoughts into two groups. Basically, there's the we want to save the world crew, and then there's the the people who label as greedy or selfish people who only do stuff for their own gains, or for the money, yeah, basically. But I'll probably say that we could do stuff that are quite fun and that could be a big boost to our career, and then we could also try and save the world in quotes, yeah, while doing that stuff that gives us fun, and then we enjoy doing a lot. Yeah. So what I'm trying to say is that saving the world and being selfish and having fun, are not mutually exclusive. So you could actually do both at the same time. Yeah. You don't have to, as I said earlier, you don't need to overthink either of both. Yeah. Okay. So thank you very much for taking your time to listen to this talk, and then I deeply apologize for the internet interruption. Yeah. So here's the link to the GitHub repository. Yeah, so the videos, the config resources, everything is right there. So yeah, if you want to try out the demo or just want to try out the work basically, and then maybe improve on it, yeah, feel free to. And of course, the papers, the publication is archived. So in case you want to, uh, read the papers, then yeah, you could easily go to archive to retrieve it. Okay, so thank you very much. And, I'm done.
Okay, Steven, thank you. Do we have any questions? Steven, thank you very much. Can
Okay.
you also drop a comment with a GitHub link?
Oh, yes, I've done that already.
All right.
Yeah.
Okay. Thank you.
Yeah, thank you for having me.